Good morning. I'm Dave Tilmouth and I'll be hosting today's webinar. John has 30 years experience working within the rail industry and has been fortunate to work in many diverse areas including freight operations, infrastructure monitoring and maintenance, vehicle testing, rolling stock production and refurbishment, and signalling. Career highlights have included being part of the team which developed the world's first high-speed hybrid train and managing the Ashford Test Centre during testing of the Pendolino fleet. John has spent time working in the United States and Japan and has been with Park Signalling for over 3 years as business development manager. So over to you, John.
So what we're going to talk about is the data link isolation transformer and the isolating surge protection units, which are produced by Park Signalling. What I'll do today, just a little process of what we'll go through, very brief background of the company. We'll talk about what the SSI signaling is and how the data link feeds into that, and then how the products that we've just mentioned here will help you with problems with your data links if you have them. So briefly, Park Signalling, who we are, most of you probably know who we are. We're a company that's been around for over 20 years now, and what we do is deliver engineered solutions for railway signalling and telecommunications. We do that in the UK and also worldwide, and we also look at expanding out into industrial control systems now. We've expanded recently, and now we've got 26 staff here, mainly engineers. They're specialists in the field, but they're highly skilled and can handle most situations, from design, explore, through to production, build, and test. We also have access to a number of associates, so we can flex the size of the business if we need extra expertise or we need extra manpower to enable us to complete projects on time. We like to think we have a pioneering approach to problem solving. We like to come up with innovative design and develop systems and solutions across the industry to really help you get the most out of your signalling systems there. So we have over 40 Network Rail product approved products which we can offer. We also offer services as well. We can do data link modeling, this kind of thing. So what we have there is a list of some of our products, both approved and ones in development. The two products we're going to talk about today are the data link isolation transformer and the isolating surge protection units, as mentioned there. So before that, we probably worthwhile looking into actually what the signalling system is that these products work with. So what is SSI? Well, SSI is a type of railway signalling system. Solid state interlocking, SSI, was first developed in the 1980s jointly under a tripartite agreement between British Rail, GEC, as was who's now Alstom, and Westinghouse, who through various acquisitions now is part of Siemens Rail Automation. So basically, it's an electronic system rather than an electromechanical system like a relay signalling based system. The same rules apply to actually how control rules or equations are used to enable safe interlocking. So SSI relies on the same kind of tables, etc., that relay-based interlocking does. So an SSI, in effect, comprises of a number of things. You have trackside equipment, such as signals and points. They're connected to things such as trackside functional modules, which you can see some examples of here. They control things such as points, signals, etc. These are actually served from the base station, from where the SSI is based, via optical data links. Example of data link module you can see there on the right-hand side. So there you can see some examples of locators and an REB. So what would happen is that the cabling would come down the tracks into one of those buildings where you would have actually the trackside functional modules which would go out there to control the equipment locally. So communication between the interlockings is controlled, as I said, by the data link. So these transmit electronic data packages known as telegrams. In effect, a data link is a twisted pair of copper cables. You have two of those for diversity and routing, and also for security. In fact, if one of the data links goes down, you can still operate the other one. Now, there are a number of advantages to SSI signaling over other signaling systems, such as relay-based interlockings. quite space efficient. If you saw the presentation last week, you'll see the physical size of relay and mechanical based interlockings. SSI, as it's computerized, reduces the space required quite significantly. The entire logic circuits, rather than being mechanical or electromechanical, are simulated in the software. So therefore, you don't have the expense of relays and wiring at the signal end of this. Obviously, because of this, it can be quicker to install as there's less actual physical equipment going in there. As there's less equipment and it's electronic, it should actually be a lot cheaper to maintain than the mechanical equipment. And also, security of that software is verified, validated, and documented. So any changes that need to be done, there's an actual process for doing that, which maintains the security and integrity of the interlocking. So there are a lot of advantages to to an SSI signaling system, but the data links themselves are probably the weakest link in that chain. So it's often thought to be the Achilles heel of the SSI interlocking system. And despite many years of standardization and provision of clear guidance, it can still prove problematic. So even if a data link is robust, when it's commissioned, changes and variations to the signaling layout over time can result in unexpected adverse consequences on data link performance. Also, as it's out there, it's a shielded pair of copper cables. It can degrade over time. And also, high-level expertise is needed to understand and make changes to maintain the SSI data links. It's not something that you can actually get any resource to go in there to do. It's a very, very specialist resource. Over and above that, they are actually prone to damage from lightning strikes, both directly and indirectly. As you can imagine, copper cabling, very good conductor. Any kind of strike from the lightning or anything like that can blow the data link and blow modules in the REBs or load cabinets. Further issue is, and this is really where we're coming on to today with these, is that there's electromagnetic interference can cause problems. So this can come from overhead line equipment, 25,000 volts, but also more increasingly recently, over the past 20 years, electromagnetic interference from AC traction rolling stock. So rather than DC traction motors, which you had previously, AC traction motors, actually with the reversing current on there, can actually set up induced problems with the data links there. So what Park Signalling have done is had a look at what we can actually do to try and minimize any problems there on the data links. And I'm probably going in reverse direction to how we develop these, but it's just for the sake of continuity, it's easier to look at it this way around. So we're talking about lightning strikes earlier, both direct and indirect ones. The problems that causes is they can actually result in large discharge of electrical energy that could pass through the data link and the signaling equipment. Actual direct strikes are quite rare, but an indirect lightning strike could cause high ground currents, and that could lead high voltage transients to enter the system through the line side cabling, i.e. the data links. So for this reason, data links are fitted with surge protection units, SPUs, capable of preventing failures by diverting these surges to earth. Now, electrified areas, as I mentioned before, 25 kV, can cause further issues through electromagnetic interference. In 25 kV AC areas, it's been common practice to use traction return earths rather than a separate earthing system. So this for safety reasons, or there might be no alternative, for example, if you're installing over a viaduct. So the effect of this 50 Hz interference can degrade components of the SPU due to constant stress, and that results in them becoming less effective as protection advisors. And that can then lead for other problems with data corruption. So at Park Signalling, what we did, we developed the data link isolating transformer, which you can see an image of here, to actually help with that. So the current practice within rail on these kind of installations of SSI, when you've got overhead line, etc., or problems with interference, is to use these data link isolation transformers to restrict common mode voltages, and that will reduce the propagation of transients. Where obviously installations do not have these devices, retrospective upgrades should be considered. So Park Signalling's data link isolation transformer provides a superior transmission characteristics over the older units, and that offers potential performance benefits. So, for example, in AC electrified areas, data link cables running parallel to the track are subject to induced voltages. The data link isolation transformers are used to electrically isolate the baseband data link sections, and that keeps the induced voltages within safe limits to enable them to carry on operation. In addition to that, the DLIT can provide protection to data link modules by limiting the common mode interference. Now, there are other isolation transformers out there, but Park Signalling's data link isolation transformer is more efficient than those other units. So that leads to improved data link signal strength, which obviously makes it more reliable. There are two versions of the DLIT available, as you can see from the drawings here. One that you can see on the left with the drawing in the centre occupies a standard single BR930 relay space in a LOC or in an REB. So that'll fit onto a standard rack. The other version, which you can see to the right, is contained within a weatherproof housing. So that can be where you can't actually mount it directly onto the equipment. That's suitable for wall or post mounting and is completely waterproof on there. So that's really covers the DLIT. What we then have here is the isolating surge protection unit, or ISPU-E. Version E is the version that's actually in use at the moment out there. So Park Signalling's isolating surge protection unit for SSI data links is an improved surge protection unit that incorporates a transformer to greatly enhance immunity to common mode surges and voltages, and it's plug-in compatible with units designed to Group Standard Engineering Standard 1937. So the unit itself there, you can see on the back, plugs directly into a base within the local REB. And in conjunction with the data link isolation transformer mentioned previously, the ISPUs can greatly enhance immunity to common mode surges and voltages. That therefore protects the data link modules from displaying faults or even failing. So as you can see, the combination of the units together gives you a very, very powerful solution. They can be used exclusive of each other, but if you are actually using them both together, that will give you the best protection you can get. So the ISPU-E was developed really to do with issues with EMC from AC traction motored rolling stock. Sorry, wrong button there. So this really stems back initially to the very early 2000s, where the West Coast Main Line was being modernised and a fleet of new trains was procured from Alstom. So that's the vehicle's known as Pendolino, which you can see an image of on the left there. So this, although there have been trains with AC traction motors on before, the complexity of Pendolino actually led to a lot of EMC issues on there. And in their current state with the signal as it was, they wouldn't have been able to run through areas that had SSI signalling in there. So what Park Signalling did, they sat down in the industry and came up and designed the ISPU, or the initial type of the ISPU, to actually enable the introduction of this rolling stock. And that was very successful. Pendolino was introduced and is running now on the West Coast Main Line very successfully with the ISPUs and DLITs there, stopping any interference problems on the SSI. Now that was 20 years ago, and things went fairly quiet apart from that since then. More recently, the new intercity express trains for Great Western and the East Coast, they found that there were a lot of interference on SSI signalling areas, causing signals to change indication, all sorts of problems on there, which were obviously very, very serious there and prevented would likely be preventing the introduction of the new rolling stock. So once again, we spoke with Network Rail and the train operators on this one and said, yes, we do have a solution with the ISPUs and DLITs, and we demonstrated to them they could reduce such EMC issues quite significantly. Now, what we managed to do with this legislation was greatly reduce the issues that came from the overall EMC envelope of the trains, and enabled these to actually be introduced now on the on the East Coast main line and on Great Western. So we're very pleased with that. We actually sold quite a few hundred of these on there to go onto the signaling units on there, and they've proved very successful since. Okay, so really that takes you through the basics of the DLIT and the ISPUs. We do have information on our website and a flyer that you can download on there. We're always open to conversations with people. If you have any issues or you have any questions on there, please feel free to email us or to contact us online. I hope you found that interesting so far, and thank you very much for sparing your time again today. So Dave, if you're there, I think you're going to just wrap up for us and go through any questions that may have been raised.
Yes, John, you've got a question here. How easy is it to install the DLIT into the SSI?
On the back. Well, that's actually very easy to install. As you can see from the image of the ISPU, which I'll go back to, you can see the pins on the back there. They actually plug into a port inside a LOC or an REB that's already there. So it's very, very simple. In effect, it's a plug and play to get those in there. Okay, Dave, any other questions?
No, there's no other questions. So I'll just remind everyone that I'll be sending out an email at the end of this to you all. If you've got any further questions that crop up, then please do submit them to us. And you can also give us your feedback on the webinar itself. We have another question just come in there, John. Why did we not sort the trains?
That's a very good question. I think the simple answer to that is that the new rolling stock is so complicated. There are so many systems that contribute to its EMC profile out there. So it's not just the traction motors, it's the onboard equipment. All these kind of things come together, and it's very complicated to pick out any particular retail or piece of equipment on there and then work back to isolate that. So fortunately or unfortunately, whichever way you look at it, it's easier for us to actually apply a control to the signalling or an improvement to the signalling system. So it's a discussion that Network Rail and the train builders and the operators should have at an early stage. Unfortunately, that doesn't seem to happen, and quite often, as in these things, signalling is the last thing that's thought of, and we'll have to actually pick up the pieces. But realistically, it's the only real solution to the problem at the moment.
We've had one response to that. It's a responsibility of train manufacturers when they're introducing new stock not to affect the old infrastructure equipment. Is there any response to that?
That's a very valid point. And in an ideal world, that would be the case. Unfortunately, that's not the case as in a reality that's out there. There are obviously an increasing number of locomotive and train manufacturers that are supplying into the UK industry. So actually, they have a lot of standard products. They try to not alter their standard products as much as possible. Obviously, for them, it's beneficial to do that. So yes, you're preaching to converted there that yes, they really should be doing more about it, but we have to be realistic and actually address the situation that's actually out there.
Okay, and another question here. How is Park's DLIT more efficient? I'm guessing that means more efficient than the alternatives or not having it at all.
It's more efficient than the alternatives in the fact that it's a newer design and it's more reliable and effective. So I don't have all the technical information on there, but in the back-to-back testing that was done, it was found to be more effective in actually isolating out these frequencies and reduce the number of failures on the data links accordingly.
Okay, a question about the ISPU. Where does it get installed? Is that in the REB?
It is, yes, the REB or the LOC. So where the data links come in, there's actually a a holder that the ISPU would directly plug into.
So DLIT along the route and ISPU in the LOC.
Yes, was the simple answer. You can do either or, but for the best coverage, then the answer is yes, both.
Do you need to remove them for testing purposes?
That I'm not sure. If you want to send me that question separately to the email address on there, I'll double check with one of our engineers. There is a procedure for obviously testing of the signalling equipment out in the LOCs and the REBs, and yeah, we can get that answer to you separately.
Right, okay, that question has now said that he's going to be quiet now. So,
They're all very good questions. Thanks for raising them.
Absolutely. So, so thanks very much for that, everyone. I'll send out an email, and that's the end of the webinar today. Thank you.